if we take a look at the graph of the sine function here, this is the graph of the sine function. If we would draw a line at y equals 0.5, this would be our line at y equals 0.5. It was a little bit slipperier than you thought they were, huh?
Yeah, and the power stuff.
Ah. Where's it stuck at?
My driveway.
You know, if you shovel your driveway and you don't have snow there, you had all day yesterday to shovel out your driveway.
Yeah.
You know that.
Yeah.
All that requires is a little bit of manual labor. That may take and put little calluses on your hands. You probably even have a snowblower at home, don't you?
I don't know. I might.
You might. You don't even know. I mean, if you have a snowblower, you can just sit there and walk behind there. I can't see Morgan not have a snowblower there. And you can sit there and walk behind. Probably self-propelled too. You call Grandpa down there. You can bring a tractor down there and plow it out for you too.
Yeah.
Now the question is the snow still there from last Monday when it snowed a foot?
Probably.
Or is it all just packed down now? So,
I don't know.
so it'd be good skiing?
Yeah.
So if we look at the sine of our graph of our sine curve, and we draw the line at y equals 0.5. What this signifies is values, theta values, where if I would, another one probably didn't have his driveway plowed. A little bit slippery on the way in this morning, huh?
No, I'll think about it.
Oh, okay. We'll give you a pass then. What we have here are values of theta so that when we take the sine of these values of theta, we get 0.5. So when I take a look, what we want to be able to calculate is we want to calculate these values of theta. So that when we take the sine of this angle theta, we get a value of 0.5. And what we have there is we have 4 specific values that are on this graph. But there's an infinite number of values that exist that make the sine of this value theta equal to 0.5. We have just 4 of them up there right now. Question is, how do we find these values? Well, in the math world, as we have gone through mathematics time and time again, there is operations that we do. And when we do these operations, mathematically, we like to be able to undo these operations. If I add 4 to something, we could subtract 4 to undo the addition by 4. If I multiplied by 5, we could divide by 5. Those are opposite operations. If I square something, we could square root it. And that's how mathematics is set up. When they developed mathematics, they developed all these operations, but they also developed these operations that allow you to undo what you did. Well, in the trig world, it's no different. We want to be able to undo what we did. Well, if we take a look at our calculator, what we see along the left-hand side is our square button, and then the second function is the square root. They're inverse operations. If I have a log, I can take whatever value I have, like whenever I take the log of, and take 10 to that power, and I'd undo what I was doing. If I would take the log of 5, I get 0.6989. Well, if I would take 10 to that power, what I come... Try that again. I take 10 to that power, I undo what I just did. When I have natural log and I have e, I undo what I just did. Well, if I take a look at my trig functions, I have sine, cosine, tangent. What we have above sine, cosine, tangent, a little bit more slippery than you thought it was coming in?
No.
Was your driveway not shoveled out?
No, I was
Oh, okay. Don't worry, Jalen. You're the only one. Everybody else didn't have problems with their driveways. Why? Because maybe they did a little bit of extra work yesterday. Above the sine, cosine, tangent, we have what is called the inverse sine, inverse cosine, inverse tangent. They are the undoing process of taking the trig function. If we would take the sine of some angle, if we would take the sine of 50 degrees, then I would take the inverse sine of that answer. I come back to my 50 degrees. Once again, processes that undo each other. So if I want to do or calculate an angle, what we have here is we have the sine of theta is equal to 0.5. What we want to calculate is we want to calculate the angle theta. Now, if you're not coming up with my answers that I just had up there as you were punching through them, you're probably in a radian mode. So go to mode and go down, I think, to the third line and make sure the degrees is highlighted. I have the sine of theta is equal to 0.5. That's these points right here. What we want to calculate is we want to calculate theta. Well, when we had 2x is equal to 10, we can divide both sides by 2. So x is equal to a value of 5. Why? Because division by 2 is the opposite operation than multiplication by 2. When we had x squared is equal to the value of 36. We could take the square root, because they're undoing processes. So x would equal plus or minus 6. Well, what's connected to my variable theta over there is the sine. And what we want to do is get rid of the sine. Now, a common mistake and a common interpretation of the sine of theta is equal to 0.5 is people want to sit there and say, well, we just divide both sides by sine. Why? Because you have sine of theta, they're right next to each other, and all we've been taught up to now is anything right beside the variable is multiplication. But when you're talking about a sine of an angle, that is not sine times theta is equal to 0.5. So what we're looking to do is we're looking to get rid of the sine of this value of theta, or the sine that's connected to theta. Well, just like when we had multiplication by 2, we divided by 2, or square, we square rooted. What undoes the sine is the inverse sine. So we could take the inverse sine of both sides. So we have the inverse sine of 0.5. So we clickety-clack that through the calculator. Inverse sine of 0.5. And you come up with what value? 30 degrees. Which in terms of radians, because I'm all up there in terms of pi, this gives me pi over 6. Which if I take a look, here's my value of pi. If I divvy this up into places, or 6 places, I would be pi over 6. The problem we run into is we get one value. Your calculator gives us one value and one value only. But what we have here is we have 4 of them up here. And if I would continue my graph on, I would have another one here. I'd have another one here. I would continue on and up. I would have another one over here. We have an infinite number of values that make the sine of theta is equal to 0.5. Well, what we calculated here is this value of theta is equal to 30 degrees. This is called the principal value. This is called the principal value. It's your calculator value. So when you talk about the principal value, it's your calculator value. When you're talking about the inverse sine, this calculator value will be anywhere between negative 90 and 90 degrees. Which means our reciprocal function, our inverse secant or cosecant, will also be between anywhere from negative 90 to 90 degrees. Which is negative pi over 2 to pi over 2. Your calculator is already set up to do this. When you deal with the inverse cosine, your inverse cosine is going to be between 0 and 180 degrees, or 0 and pi. Once again, you don't have to sit there and work yourself through this because your calculator will give it to you. Your calculator is programmed to give you the principal value. And if you remember back in trig class, we did some general formulas off of that. And those general formulas then would give us all the values. We don't quite get into that in the pre-calc world. We just look at the principal values. When you deal with the inverse tangent or arctangent, once again, your calculator is set up for this. You're between negative 90 and 90 degrees. This is where you have something a little bit different. The cotangent. The cotangent is between 0 and 180 degrees. That's the only one that's a little bit different. When we have a letter there, it tells us that we have to keep our things in terms of radians, in terms of pi. My suggestion to you is keep your calculator in degree mode. Keep your calculator in a degree mode. Find a degree measure to this, and then we can convert this to a value of pi. So in your calculator, you can do your inverse cosine of negative 1/2 in a degree mode and get a degree measure. Justin, what do you come up with?
120.
120 degrees. And then from this point, we can convert this into terms of pi. So you can use your pi over 180 equals x over theta. But what I like you to do is start to advance yourself. You can go, once again, you have pi over 180 is equal to x over 120. Do your cross multiply and divide if you wanted to. But we can start to advance ourselves a little bit and start asking ourselves the question, which one of these values here, 30, 45, 60, 90, can we multiply by a specific value to get 120? 30, 45, 60, 90. Can I multiply any of those values by a specific number and get 120 degrees? Yeah, can we? Which one? Yeah, we can multiply 60 by 2. If we multiply this by 2, we get 120. But what we do to one side, we must also do to the other. So we're left with 2 pi over 3. You might be sitting there saying, well, if I would multiply that by 4 and that by 4, that would be the same thing. But what you're left with is 4 pi over 6. 4 over 6 reduces down to 2 thirds. 4 pi or 2 pi over 3. Solutions need to get back into radian mode in terms of pi. Well, what happens when we have the inverse cosecant of 2? I don't have the inverse cosecant button on my calculator. I got my inverse sine, cosine, tangents. I think you can, there is something somewhere, but there's way too many buttons for me to sit there and have to push to be able to find it. You would have to go into your catalog. You'd have to go into your catalog and try to find it in your catalog. But we can write this as a reciprocal function, the inverse sine, because the sine is a reciprocal to cosecant. I reciprocate my trig function. What do I think? What do you think you have to do with the value of 2? What would we do the inverse sine of? Oh, what do you think? Inverse sine of what? 1 over 2. We reciprocated the trig function, so we're going to reciprocate our value. So we have 1 over 2. So we have the inverse sine of 1/2. So you find a degree measure, and then change it in terms of pi. Emily, what did you come up with? Go ahead and do the inverse tangent of square root of 3 and inverse sine of pi. All right, we will stop there today. We'll pick up tomorrow. You have no homework for tonight. Adios. Have a good day. Enjoy the snow tonight.